Inverse functions. We're going to start, we were looking at function composition. It kind of goes hand in hand with inverse functions. So we're going to move into that today, and then I'll show you your assignment for the week. So let's see. Man, we're still missing like 7 people. Well, they're just going to be coming in late, I guess, because we're not going to keep waiting on them forever. All right, let me put this up on the screen, and we'll start with our notes. These notes, let me double check. I think I've got them loaded in Google Classroom. Yes, class notes for the week. So again, if you like printing off the notes and fill them in with me, or follow along, or just having some pencil and paper to take notes on as we do this, that wouldn't be too hard for this week, for most of the notes anyway. Page 2, we'll get into a little graphing, but we'll use decimals for that, so it won't be too bad either. So I'll put this up on the screen, our notes that we're using, and you can follow along however suits you. But I suggest you be writing some examples and stuff down somewhere so you can use them on tests and quizzes and assignments and everything and know what you are doing. So, all right. As we were talking about last week, we had composition of functions, right? F of g of 3. So let's go back and review first. What do we do? F of x. Instead of f of x, we got f of 5. So you remember what we do with the 5? Somebody put that in the chat. What do we do with that 5 when we see f of 5? Replace the x with 5. Plug it in there. Oh, good. You guys are right on top of this. Right. So when there's a 5 there, that means the x is going to become a 5. So f of 5, 2 times 5 plus 3. We know that equals 13. All right. That's not hard. Same thing with negative 1. 2 times negative 1. Negative 2 plus 3. That's just 1. 12 would be 2 times 12 plus 3. 27. Those are simple. But tell me, g of x is over here. Let's go ahead and just look at these like g of 1. 1 minus 3 is negative 2 divided by 2. So that's negative 1. 27 minus 3 is 24 divided by 2, 12. So we can do the same thing. But what is f of g of 3? I'm going to let somebody calculate that and see what we get in there. You guys were right on top of the replacing the x, but now instead of putting a 12 in for x, I'm putting g of 3 in for x, right? Because that's what it is. It's right there inside the parentheses. G of 3 goes in for x, which means I need to know what g of 3 is. We didn't calculate that over here, so let's add that to our list. What is g of 3? So g of 3, 3 minus 3. You guys are ahead of me on this answer. Good. 3 minus 3 is 0 divided by 2. So g of 3 is 0. So this is the same thing as f of 0, which 2 times 0 is 0. So yeah, it's just 3. And some of you guys were already ahead of me. You had that in the chat. Good job. You guys are on top of that. So yeah, since it's g of 3, we find out what g of 3 is. Substitute that in for the f. Now let's look at this. Oh, let's do this one first. Let's do it backwards. G of f of negative 13. We did not find f of negative 13. So we have to find that first. 2 times negative 13, negative 26 plus 3. Don't mess it up. Negative 26 plus 3 is negative 23. So this would be g of negative 23. What is that going to equal? I see a negative 13. Ryan's already on top of that. Negative 23. Negative 23 minus 3 equals negative 26. Negative 26 divided by 2. Great job, Ryan. On top of that, negative 13. All right, so when we substitute g of 3 into f, we get 3. Substitute f at negative 13 into g, we get negative 13. That's interesting. That's interesting how that turned out. Turned out to be the same number for some odd reason. Well, let's find out what f of g of x is. Now, we don't have a number, so we're actually taking this whole equation and substituting it in for x. Taking the whole equation. So which means that's going to equal x is going to be x minus 3 divided by 2 plus 3. Right? Now we have to simplify that. So what's that going to simplify to at the end? Take that in your notes. Look at that. 2 times x minus 3 divided by 2 plus 3. Simplest answer. What when you get down to the very simplest answer, you do all the math. What is that going to equal? Okay, Brianna's got an answer down there. So if x minus 3 is divided by 2 and then multiplied by 2, x minus 3 is divided by 2 and then multiplied by 2, that's just going to be x minus 3, right? Like pretend if that was 10, 10 divided by 2 is 5, times 2 is back to the 10. We're back where we started. When we divide by 2 and multiply by 2, those just kind of cancel each other out because that's just doing the opposite. We divide by 2, then we multiply by 2. That puts us right back where we started. And then we still have the plus 3. So we got x minus 3 plus 3. Well, if we subtract 3 and add 3, that's just like dividing by 2 and multiplying by 2, right? So this is going to simplify to just be x. See how that works? Well, that's interesting. Let's go the other way. Let's take f of x and substitute it into the g of x equation. So the g of x equation is x minus 3, but instead of x, we're going to put this, right? 2x plus 3 minus 3 divided by 2. 2x plus 3 was substituted in, and then minus 3. You can put parentheses if you want to help keep track of the fact it was substituted in for x, divided by 2. So let's simplify that. 2x plus 3, we can take away the parentheses because there's nothing outside to multiply in. It's just a 1 outside. There's nothing out there to multiply in. So it's 2x plus 3 minus 3. Well, if I add 3 and subtract 3, what do I got? I got 2x, right? 2x, I add 3 and I subtract 3. Those just kind of cancel each other out. And then we divide it by 2. So 2x divided by 2. 2 divided by 2 equals 1x. So it just equals x. Well, that explains. See, when you substitute x in there, we ended up with x. That explains why when we substituted negative 13 in there, our answer was negative 13. And when we substitute x into this f of g of x, we ended up with x. So that's why when we substitute 3, we got 3. Well, let's try that with these equations then. We're going to zoom in a little bit better because I know that's pretty small. All right.
I was about to say that. I was like, Robert, where's your camera?
All right. So f of 5 for x cubed plus 1. 5 cubed. So that's 5 times 5 times 5. And then we add 1 to that. 5 times 5 times 5, or 5 cubed. Anybody know that off the top of their head? 5 times 5 times 5 plus 1, 126. Yeah, you guys got it. So when we add the 1, it's 125, and then add the 1. All right, negative 1. What is it when we substitute negative 1 in for x? So negative 1 is cubed. Negative 1 times negative 1 times negative 1, and then add 1. Times negative 1. So negative 1 times negative 1 is a positive 1. Positive 1 times a negative 1 is a negative 1. Plus 1. 0. You guys already had all them zeros on the chat. F of 2. 2 times 2 times 2 plus 1. 2 cubed. All right, you guys are on top of it. All right, let's look at G over here. G of 126. So we've got to substitute it in to 126 minus 1 and take the cubed root of that. So the cubed root of 125 when we subtract 1. So the cubed root of 125, what multiplied times itself 3 times equals 125. Well, we just figured that the other way over here. 5 times 5 times 5 is 125. So this obviously must equal 5. How about G of 0? So 0 minus 1, it is the cubed root of negative 1. Now, the square root of negative 1 does not exist. But the cubed root does exist. We can multiply by something by itself 3 times and get a negative number, as long as it's a negative number to start with. A negative times a negative times a negative is a negative. So the cubed root of negative 1 equals negative 1. Negative 1 times negative 1 times negative 1. So that equals negative 1. G of 9. 9 minus 1 is 8. What's the cubed root of 8? What do you have to multiply by itself 3 times to get 8? Are you noticing what's going on here? We didn't do G of 13 up here, but it's 5. You know what's going on here?
Interrograde. Water bears. We're not gonna actually go with that. Anyways, from then on,
whenever we substitute one number into one of the functions and then take the answer and we're substituting it into the other function, we get back to the first number. That must mean something. F of G of 3. What do you think that's going to be? F of G of 3.
And then these creatures right here are
Okay.
So you got to put 3 in the G, and then whatever you get there, you substitute in the F.
What that means basically is that during embryonic
Tell you what, let's look at this first. What are you thinking about that? Because that would be the cubed root of 2. And then you take the cubed root of 2 over here and cube it and add 1. Let's look at f of g of x. F of g of x, we take g of x and we substitute in here. So it would be the cubed root of x minus 1. And then we want to cube it. And then add 1. What is the cubed root of x minus 1 after we cube it? Well, the cubed root of anything, once you cube it, those cancel each other out, and it just would be whatever's underneath there. So in this case, it would just be x minus 1, and then we got a plus 1. So when you substitute g of x in there into f of x, you get x. Let's look at it the other way. Take this. Cubed root of x is x to the third plus 1, and then there's a minus 1. So that's going to simplify x to the third plus 1 minus 1. Well, that's 0. So it's just the cubed root of x to the third power. The cubed root of x to the third power. That's like taking the square root of x squared. Square root of x squared. Well, it's just x. The cubed root of x to the third, that's just x. The 23rd root of x to the 23rd would just be x. Because these cancel each other out. When you take the root of something and it's the same as the exponent of something, those cancel out. Because another way to write the cubed root is to say x to the 1/3 power. 1/3 power is the same thing as the cube root. Times x to the third power. We know with exponents, we're allowed to multiply. So it'd be x to the 1/3 times 3 power. Well, 1/3 times 3, x to the first, which is just x. They cancel each other out, guys. If you got x to the third root, x squared to the square root, x to the 23rd to the 23rd root, it's just whatever's being put underneath there. So when we got this, it just equals x. So knowing that, whatever we put in here, it's going to equal that. That really saves us a lot of work here. This is going to equal 3. This is going to equal -7. Because we know that whatever you substitute in there is going to end up that answer. So we're substituting a 3 in there. It's going to end up a 3. Substitute -7. It's going to be a -7. Does that work with everything? No, it doesn't work with everything. But there's just something special about f of x and g of x is they are inverses of one another. These are inverse functions. It doesn't work with just any two functions. It only works if they are inverses of one another. So here is an exponent and a logarithm. Exponents and logarithms are opposites. They are inverse functions. And so since this is to the x and this is log to the x, these are inverse functions. This is going to equal x. This is going to equal 4. This is going to equal 1. These are going to end up each other here. 0.5 is going to be the square root of 2. This one's going to be 0.5. We're going to see the same thing because they're inverse functions. All right, so we're going to look at some inverse functions on a graph. So let me pull up a Desmos graph here.
filter out water and to catch the food. They have these little
All right, before we graph this, we're going to leave it in the screen where we can see.
so they help that.
So y equals 2x plus 3. Okay, that was that first one we had on the other side. And then y equals, if I want x minus 3 to be above that, I need to put it all in parentheses. X minus 3 divided by 2. And see, if I don't put the parentheses, that just says y equals x minus 3 divided by 2. It only does the 3 divided by 2 because that's the last number. I have to put it all in parentheses for it all to be divided by 2. That's important to get that right. All right, let's look at the graph. This is the graph of those two functions that are inverses of one another. What do you notice about them? Do you notice anything interesting?
Okay, so what are some other characteristics? The sponges are
They cross into each other. They do.
all kinds of shapes and sizes. They are sexile.
Yes, they intersect.
So it's not like they get up and move around. They're just going to be.
Come on, let me put our second problem that we had on there, and we'll look at those two. Y equals x squared plus 1. Let me turn these off for a second. We're just going to look at this. X squared. Oh, it was x cubed. I'm sorry. X to the cubed plus 1. And then the other one we had was y equals the cubed root. I think I need to get into their extra functions down here. Do I have cube root in here somewhere?
So piece it like the falls off and it can form.
Where is it? Oh, there it is. The cubed root of x minus 1.
And then you have
Okay, so here's all 4 of them.
inside the body.
Yeah, so what I'm saying, they intersect at -3. The first two did. Here, I can change the settings to make that easier. Tell it to step by 1 and turn off the minor grid lines. And now it's just everything's by 1s. So yeah, these intersect at -3. So I'm gonna turn those off again for a second.
And that's what and it's different.
Interesting.
The second kind is definition of that is it is a matrix in skeletal.
They look opposite. Opposite in what way? I mean, what would they be? You're right. They are opposite, but they're opposite specifically or something. I'll even do the logarithm one on here. So if we had y equals 2 raised to the x power, turn off these others so we can see it. And y equals, let's see, I think I have log functions down here. So was it at the bottom? No.
So
There it is. Log 2 of x. So there's the logarithm ones. There's the x cubed with the cubed root one. They kind of mirrorish. Yeah, they are. The question is, if they're a mirror, what are they reflecting over? What's the middle of the mirror? It's not the y-axis. It's not the x-axis, right? It's not. If we turn off some of these where we can see just 2 of them, that's not reflecting over the y-axis. That's not reflecting over the x-axis. Any idea what it would be reflecting over? The origin? Well, if it was reflected over the origin, then this point right here would exist over here also. So that's not exactly it. I like your guess, though. Let's go to these straight ones. They're a little easier to look at. Yeah, if it's over the origin, if we have a point here at 3, 0, it would also be at negative 3, 0. So it's not over the origin. But I do want you to notice this. We have this point, and we have this point. We have this point. Come on, point. It's not giving me that point. And I'll just make the point. Negative 2, negative 1. And we also have the point negative 1, negative 2. Make those 2 points. The y equals x line, says Ryan. Let's put the y equals x line on there. That black line is the line where y equals the x. Y equals the x. And it is. That's what it's reflecting over. The y and the x, if y equals x, that means they trade places. This one has negative 1, negative 2. So this one has negative 2, negative 1. They traded places. This has the point 3, 0. So this has the point 0, 3. The x and the y equal each other. They trade places. Whatever the x was here is the y there, whatever the y was. And that's even true in the weird places. Like if we can find this point, 1.47, negative 765, that means we can find a negative 6.5 over here somewhere. 1.48. It's not liking the 0.5s, but all the points you can find here. 1, negative 1 means we can find a negative 1, 1. Oh, there it is, negative 1, 1. Because the y equals the x. Let's take off the straight line and put on the x cubed. Yeah, it is reflecting over y equals x. Let's do the logarithm and the exponent. Reflecting over y equals x. So what we've learned is inverse functions reflect over y equals x. So if you draw that y equals x line, oops, I do have a ruler right here. Five, 5, 10, 10. Everywhere the y equals x. That's what we call it, the y equal x line. 3, 3, 7, 7. Every time the x has got a number, the y has got the exact same number. They equal each other. That will be the line that the functions will reflect over. So that 2x plus 3 goes up by 2. So that is one of the functions. And the other one's over here at 3 and goes by 2 that way.
And then remember that the larva is a
reflects over that y equals x. So that is those 2 equations right there. So if we look at the points, so this is g of x. This is f of x. If we look at these points for f of x, this is the point 0, 3. The next point we see here is 1, 5. The next point we see is 2, 7, which means it's also got 3, 9. So that's the points that we see on f of x. If we look at the points on g of x that correlate with these, we see the point 3, 0. We see the point 5, 1. See the point 7, 2. Which means we'll also see the point 9, 3. So you see what's happened there to the points that appear in one function. 0, 3, 1, 5, 2, 7. Those become the x's in the other function. And then the ones that start as x's, the zeros, they become the y. The 1 becomes a y. The 2 becomes a y. 3 becomes a y. They trade places. when they reflect over y equals x, suddenly the y equals the x. The y equals the x, and the x will equal the y. The x equals the y. So that's an important thing to note on inverse functions. This is only true for inverse functions. Not every function has an inverse, but if it does have an inverse, then you're going to see the same pattern. It's going to reflect over that, and it's going to have those points right there. They'll reverse. The x will become the y's, the y's become the x's. Okay, so with that, I want to look at, we haven't learned how to find the equation for it yet, but I want to look at the first two problems you see. Find the inverse for each of these relations, and I give you points. Now, the rest of this is finding an equation for it. Well, these last two, you know how to do. Solve for f of g of x, where you take g of x and substitute in there, and this is f of g of 8. Find g of 8 and substitute in for f. But let's talk about these ones in the middle, because you've got 6 problems here that you have to find the inverse. So we've got to be able to find the inverse for this. So how do we do that? All right, well, let's turn it over and look. So if we have a function, all right, this is going to be our function. And let's say it equals 3x minus 7. All right, let me bring it back up here. We have this function, 3x minus 7. And we want to find the inverse. Now, the inverse can be noted like this, f inverse x. In function notation, that is the inverse function. And this is how we find what the inverse function is. We change this first to a y equals, because that's the same thing, right? Y equals an f of x equals 3x minus 7. So first change to y. First thing I put in my notes, change it to y equals. Next, swap x and y. We're going to swap the x and y, which means this is going to be x and this is going to be y. See all we did is swap those. The x went where the y was, the y went where the x was. Swap those. Now, solve for y. We want to get to y equals. We got to get y by itself to where it started. Started as y equals, we want to finish as y equals. So the first thing we need to do, if we have 3y minus 7, we need to move the 7 away from the y. So now instead of just x, we've got x plus 7 equals, this is 0, so all we have left over here is 3y. We're getting close. We don't have y equals, we have 3y equals. So let's divide both sides by that 3. So y equals x plus 7 divided by 3. That is the inverse of f of x, x plus 7 divided by 3. These two functions are inverses of one another. How can we test that? Well, let's substitute one into the other one. Let's take x plus 7 plus 3 and substitute 3x minus 7. 3x minus 7, put that in for x, plus 7 divided by 3. See, I substituted that in. So 3x minus 7 plus 7 equals just 3x divided by 3 equals x. If you can substitute one function into the other function and it equals x, and you can substitute that function to that one and it equals x, then they're inverses. So let's substitute the other way. 3 times x plus 7 divided by 3 minus 7. Divide by 3, multiply by 3, they cancel each other out. So that's x plus 7 minus 7, which is also x. So that proves, since they both equal x, when we substitute them into each other, This was G of F of X. This is F of G of X. Since they both equal X, then these are inverses. Oh, we're in my E and R together. They are inverses. Yes, we have checked it. So that's how you find the inverse equation. Let's do one that's a little trickier. Let's say that f of x equals x to the third divided by 5 equals x to the third divided by 5. So following our rules, first we change it to a y equals x to the third divided by 5. Then we swap them. X equals y to the third divided by 5. Okay, we swapped them. Now we solve for y. Well, if y to the third is divided by 5, then we want to multiply it by 5, which means we have to multiply this by 5. So 5x equals y to the third, because dividing by 5 and multiplying by 5 just cancels each other out, leaves y to the third. We don't have y yet, but we're close. So if we take the cubed root of both sides, the f inverse y is all left over there, and this is the cubed root of 5x. That cannot be simplified any further. The cubed root of 5x is as simplified as it gets to be. But these two are inverses of one another. If you substitute this in, you'd have the cubed root of 5x, and then you're going to cube it, which means it's just 5x. 5x divided by 5 is x. You go the other way around. Excuse me. Other way around. 5 times x to the third to the fifth. Well, divide by 5 and multiply by 5 means it's just x to the third. So the cube root of x to the third is just x. So it equals x both ways. These are inverses. Check. They are inverses. So that relates to the other 6 problems you have. Find an equation for the inverse of this. Find the inverse. You can also note that since that's y equals, if this is the problem, you can also do y prime. You can put the same little note up there, and that would note that that's the inverse. That's the inverse. Find an equation for the inverse of this, negative 5x minus 7, x squared minus 4. Here's one with a parenthesis, with a fraction, x plus 5 divided by negative 5. Here's one where you start with the square root, and you find an inverse, and then negative 3/4 x plus 5. So you got those 6 problems in the middle where you find the inverse. You have the first 2 where I give you points, 4 points. Each of them have 4 points. Tell me what the inverse relation is. What's the inverse? If this function has these 4 points, what 4 points do you know are in the inverse? And then these last 2 where you have f of x and g of x. These are ones you show your work. So when you click on that, it'll open up this other window, and you can use the pencil to scribble. You can click this to type if you want to type your answer. You know, you can type your answer if you want to work on it. But just show your work. Show how you put g of x and substituted it into f of x, where the x is, and then worked it down till you had it simplified. So it has that right there for you. And same thing on this, except you have g of 8. G of 8 that's being substituted into f. So 10 problems, 3 points each, 30-point assignment, all about inverses, finding inverses, working with inverses. I understand. I didn't do any graphing. Graphing is just kind of a pain on formative, but we'll probably do some at some point. So All right. Any questions? We kind of understand inverse a little bit. That we get in there and play with it. I'll have this video posted. I got 3 videos to post right now for today. As soon as I get it edited and it processes it all, it'll be posted to Google Classroom. Hopefully today, maybe tomorrow morning. I do have a bowling match today, so I have to leave here promptly. So, any questions? All right. Well, I will let you guys go then. You got a lot to digest. You've got your assignment for the week. I'll be getting the grades in as soon as I can because you need them for advisory tomorrow because we're doing grade checks this week. So I will get those in and we will see you next